Good morning everyone. I hope everybody is doing fine. So last numerical done of limits and derivative were question number 27 in the class as well in the video. So now moving on to question number 8. I hope the limits concept, the left hand and the right hand limit is clear to you all. So question number 28 says that a function has three values for x less than 1, equal to 1 and greater than 1. And if limit x tends to 1, f of x is equals to f of 1, what are the possible values of a and b you have to calculate. So first you know that if limit x tends to 1, f of x is equals to f of x, therefore limit left hand limit and the right hand limit both will be equals to f of 1, okay, for the limit to exist. So left hand limit x tends to 1 minus will be choosing the upper one, and the right hand limit for x tends to 1 plus will be choosing the third function. Okay, so I substituted the values for 1 in x less than 1, like we have out here a plus b, and for the second one a b minus a, and we have f of 1 is equals to 4 as given in the question. So both of the functions you put it value of 4 and then you solve it simultaneously by elimination method. You will get the answer of a as 0 and b as 4. Okay, so your respective values for a and b will be 0 and 4, for which the limit x f of x is equals to f of 1. Is it clear? I hope this numerical is clear to everyone, because if limit is existing and they have already given in the question that limit extends to 1, f of x is equals to f of 1, therefore your left hand limit is also equals to f of 1 and right hand limit is also equals to f of 1. And in the previous class we had already covered 6 to 7 numericals based on left hand and the right hand limit. So I hope this will not face any people don't face any confusion regarding this. So kindly copy it down. And moving on to question number 29, I told you in the class to do it as a homework. For people who haven't done it, kindly look into it now. Now look very carefully. Limit x tends to a1. So you automatically see that x tends to a1, you'll get an answer of 0 out here, because x tends to a1, when you put out here x a1, then you'll get 0 for entire, for the first one, and 0 multiplied by anything is 0. So after having put that value, you have to put it separately out here and dot 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 till the last function. And if since first only you are getting 0, therefore doesn't really matter if you continue writing. So you just write three of them, first two and the last one, and then write it multiplied by 0, you get an answer of 0 directly. Clear? So that's it for this numerical. That is as simple as that. Now moving on to question number 30. For what values does x tends to a, what values of a that limits exist. So a you can choose basically three values. One is less than 0, one is equals to 0, and one is greater than 0. Okay, out here you have to be very careful. First you choose when it's equal to 0. Okay, when it's equals to 0, you have to check that left hand and right hand limit exists or doesn't exist. So for 0 less, you will choose the chop function in which mod x will be minus x. Okay, you'll get the value of 1. And when you choose greater than 0, you'll choose the third function which x is greater than 0. Then you put x value as x, and when you put 0 out there, you'll get minus 1. So limit does not exist for a equals to 0. This condition is nullified. Now when you put a greater than 0, now since a is greater than 0, you'll always choose the third function. Okay, this is for they've done for a less than 0, then you'll be choosing the first function in the both the cases, in which both a x's will be negative, turning out your answer comes out to be minus a plus 1 and minus a plus 1, for which limit is existing. Okay, so limit exists as s is equals to a when a is less than 0. For all a less than 0, you will have limit existing at x is equals to a. Okay, now the third condition is x is greater than 0. You will be choosing the third function in which x will always be greater than 0, because a, the value of a which you're choosing, it's always greater than 0. Okay, so in both the cases you get a minus 1, a minus 1. So limits exist at x is equals to a when a is taken as greater than 1 as well as less than 1, but not is equal but does not exist when a is equals to 0. Clear? Kindly copy this numerical, entire numerical, by pausing the video and moving on to the next one. You have, if the function satisfies this thing, okay, the condition has been given to you. Evaluate the limit x tends to 1 for f, limit x tends to 1 f of x. So you simply substitute the value f of x out here first, okay, and they have given you it as equals to 1. You separate this thing both and put it to RHS. Simple basic algebraic calculations are to be done out here, okay. So after having put these values, your limit x tends to 1 f of x will come out to be 2. Clear? So after doing this numerical, move on to question number 32. 32, I'll give it to you to do it on your own. For what values of m and n limit x tends to 0 and x tends to 1 exist? So for x tends to 0 you'll get one value, and for x tends to 1 you'll get other value for m and n. Okay, so I'll tell you, for x is equals to 0 you'll choose first two functions, and for x is 1 you'll be choosing second and third function. First and second function will be chosen as the done in the uh, third numerical to discuss today. It is as same as that, okay. So kindly do this numerical and let me know if you have any difficulty, and all the very best for your exams, the upcoming exams. 3 days, make sure you submit your assignments on time and your test papers also by writing your roll numbers, okay. So thank you, bye bye, have a nice day.